We have an encoder that is capable of processing different types of input, such as images or sounds, once it has been trained. For example, if the encoder has been trained on images, it can identify patterns within those images. Similarly, if it has been trained on audio, it can recognize patterns in sound. The encoder processes this input and converts it into a set of query, key, and value representations. These embeddings capture the relationships and similarities within the data. Once this is done, the output is passed to the decoder, which generates the final result. In the case of images, the decoder produces a caption describing the content of the image. For audio, it can convert the sound into text, effectively translating the voice into written form. The encoder handles the understanding and representation of the input, while the decoder is responsible for generating meaningful output based on that information. This setup is what makes multimodal models powerful. The encoder extracts patterns and context from images or sounds, transforming them into embeddings. The decoder then uses this contextual information to produce captions, translations, or other forms of output. For instance, after the encoder has processed an image, it is aware of the category or context the image belongs to. This context is passed to the decoder, which generates a descriptive caption. The same process applies for audio. The encoder identifies the context, and the decoder converts it into text. In summary, the encoder handles the input processing and pattern recognition, while the decoder generates output, making the system capable of handling multiple types of data. This is the core idea behind multimodal encoder-decoder models.